Hello everyone. I am Uttam Satpute, Professor Electrical Engineering Department at Dr. D.Y. Patil Pratishthan's College of Engineering, Salunkinagar, Kolhapur. This is a video on traction moment and energy consumption of the subject electrical generation and utilization of 8th semester. In this video, we will learn the second speed time curve, which is an approximation to the urban service system, that is quadrilateral speed time curve. So in my previous video we have learned trapezoidal speed time curve, which was the approximation to main service line speed time curve, and this is the second quadrilateral speed time curve. Now here also we have to find out the parameters. We have to find the equation, the main parameters. The first one is the crest speed. Crest speed. So the equation to find out the crest speed in this quadrilateral speed time curve, then the average speed, and then the schedule speed. So these three parameters, as we discussed in the previous video, we have to find out for the given speed time curve. Now this is the speed time curve, which is approximation to the urban service line. So what are the parameters will be given in this speed time curve? Please note down. The first, they will give the acceleration in the acceleration phase. So 0 to t1 is the acceleration phase, and it is accelerating at the acceleration of alpha in kilometer per hour per second. So please note down this unit. It is kilometer per hour per second. So speed is in kilometer per hour, and because the time we are taking it in second, the slope unit it becomes kilometer per hour per second. Then the coasting retardation. So this is the coasting phase, and what is the acceleration or retardation? Here it is beta c. And braking, this is the braking phase, and here the retardation is beta. So these acceleration and retardation in various phases are given, and two speeds, maximum speed, this is what we are interested in, crest speed, maximum speed at the end of acceleration in kilometer per hour. So this is the v1 value, the maximum speed that is attained during acceleration. And after coasting, the speed which has reached, that is v2. Now these five parameters, acceleration and the two speeds, will be given to us, and one more parameter, that is time, the time between start and stop of the vehicle. Now from these six parameters, we have to calculate the we have to calculate the these three parameters. So let us derive the equations. So here the first equation is uh, time of acceleration. So let us first find the time of acceleration. So what is the time taken in the acceleration phase or vehicle to move from zero speed and to attain v1 speed? So during this acceleration, as yesterday we have seen the equation for acceleration, it is equal to v by time. Okay, it is actually dv by dt, but for linear motion, we can write it as v by t. So t time, we can say it is v by alpha. Simply we have to divide the speed divided by acceleration to get the time. So during this t1 phase, what is the speed? The speed is v1, that is at a v1 minus 0. Actually it is v1 minus 0. Okay, and so it is v1. And what is the acceleration? Acceleration is alpha. So we'll get t1. So T1 we find out here the time during acceleration, then the time during coasting. So during this the time is T2, and the speed it is V2 minus V1 minus V2, or V1 minus V2 is the it is the change in the speed. Speed is V1 minus V2 and acceleration is beta c. Then the time in braking. During braking, T3 is the time and speed is V2 divided by acceleration is beta. So this one equation, acceleration, or this equation, it is used to calculate the time during different phases of this. So first you have to calculate the times T1, T2, T3. Then here it is calculated the uh, distance. The distance, total distance covered from start to stop. So here we have seen this is the trapezoidal speed time curve. So let us divide this into these sections. So now we have to find out the area. Distance with the total area under this curve. So this area plus this area plus this area. So if you add, then we will get the total area which is equal to distance covered. So distance traveled. So here it is calculated. Now this equation gives you the area under acceleration phase. During acceleration phase, this will give you the area. Now because this is a triangle, we know that the area of the triangle is half base into height. So half base is T1 and the height it is V1, and it is divided by 3600 so that we get the distance in kilometer. In the distance we get in kilometer. Okay, and because at hour we are converting kilometer, as we have seen kilometer acceleration it is in kilometer per hour per second. Okay, so now this hour we are converting it to second. So okay, so for that reason, so answer finally we get in kilometer. So this is the equation to calculate the area under acceleration. And the second component it is to find the area under this trapezoidal part. So how it is calculated here, the average, this is V1 and this is V2, the average of these two is taken, that is V1 plus V2 divided by 2, that is the height. This is the height into base is T2. T2 is the time, and divided by 3600 as I told to convert hours into seconds. And this is again area under triangle. This is the triangle. So it is half B into H. So with this way we calculate the distance, and now it is simply the manipulations here. V1 T1 divided by 7200, it is simply multiplication of 2 into 3600. Then V1 into T2. Now like that it is done here. Then V1 by 7200 is taken common, T1 plus T2. Then V2 7200, here also it is taken common, T2 plus T3. And then now here what is done, this T1 plus T2 it is substituted by this. This is as per this equation. Okay, this is as per this equation. We can see here from this equation we can get T1 plus T2 is equal to T minus T3. Okay, so this T minus T3 it is substituted here. Similarly, T2 plus T3 it is also substituted as T minus T1. So from this equation, T2 plus T3 it is equal to T, and this will go on this side, it become minus T1. So we will get T minus T1 is substituted here. Okay, now next. Okay. Then again, now it is substituted. Now t it is taken common, and then it is v1 plus v2, and here some manipulation is done. Now here t3 it is substituted, t3 time it is substituted by this. This is t3 substitution here. This is t1 substitution here. Okay, and then we get this equation something like this. So it is V1, V2, 7,000. Now here 7,200 is taken on left hand side, and T V1 plus V2 minus V1 V2 1 alpha 1 by alpha plus 1 by beta. So we come to one equation. This is equation number A. We will call it as equation number A. Now in this equation we have two parameters. You see here there are two unknowns, V1 and V2. V1 and V2 are the two unknown in this equation. Okay, alpha is known, beta is known, T is known. Only okay. So yes, I think yes is also there on this side. Okay, now this is another equation that is developed for to have a relation between V1 and V2. Here V2 is V1 minus, this is from our equation of beta C. Okay, so beta C or T2. T2 we have seen it is V1 minus V2 divided by beta C. So V2 it is find out from this equation. So V2 is equal to V1 minus uh, beta C uh, beta C into T2, and V1 minus beta C. T2 is substituted like this: T minus T1 minus T3. T3 is substituted by V by alpha. T3 is substituted by V2 by beta, like this. And finally, we come to this one equation. So this is the equation what we get. Uh, uh, so this is the equation what we get for you know for v1 and v2. So using this equation a and b, using equation a and b, we will find out v1 and v2. And once we get v1 and v2, then we can find what is the value of s, that is distance, and from the distance we can find the average speed and also the we can find a schedule speed. So these three parameters we can calculate. So in quadrilateral, we have to remember these two equations A and B, which are used to find out V1 and V2, and then we can find S, and from there we can calculate average speed and schedule speed. So in this video, up to this only. Thank you very much.